Welcome, everyone, to this first Oracle on VMware Elite panel. What we've assembled here for you is a set of luminaries in this particular field throughout North America. And today, what we're going to be doing is asking them a series of questions. The questions that we've compiled over quite a long period of time from various different blog entries, from other types of questions that just happen to, in general, roam around the internet, and from a lot of customer contacts. My name is Don Sullivan. I am SE Database Specialist for North America, specializing, of course, in databases, but in particular in Oracle. I'll give you a little bit of an introduction of myself. I'll let you know some of the ground rules here, and then I'll introduce each of these gentlemen. I'm going to have them stand up during the introduction. You can applause then. But please, during the event, let's try to keep our applause down to a minimum, if nothing at all, and we'll do it all at the end because there's going to be an enormous amount of content here in the next hour. The ground rules basically are each one of these folks are going to get a series of questions that are somewhat randomized. These are subject areas that they're all very familiar with, and I will tell you that every one of these guys can speak to each one of these subjects for 2 hours, and I'm going to ask them to do it in 2 minutes. So we're going to really get a lot of very thick, very intense content. And I might, at different times, ask for different responses to certain comments. And at the end, we'll actually have a little bit shorter questions as well. So again, there's going to be a lot of very intense discussion here overall. Now, this particular program is the beginning of what is effectively a huge marketing effort that's going to include software release, demo software release to a group comprised of the Oracle ACEs and Oracle Certified Masters around North America for the purpose of basically comprising an elite testing squad to be able to compare various different hypervisors that are out there in the industry, some of which you know about and some of which you might not, to compare both features, manageability, and even performance-oriented issues. So this is the beginning of this. We hope to have a lot of these panels, hopefully around the world. But this is the inception, as I said. So again, my name's Don Sullivan. Been with VMware for about a year and a half. I'm an Oracle Certified Master. I spent 7 years as an instructor and a consultant with Oracle and about 5 with HP. Been here again about a year and a half. So let me introduce the individual guest panelists. Charles Kim of Viscosity Technologies, an Oracle ACE Director. He's a certified DBA, RAC expert. Professional focus is on maximum availability architecture, RAC, ASM, DataGuard. Met with and known Charles for quite a while. He is an absolute luminary in industry. As you can see, he's co-authored 3 different books: Oracle Database 11G New Features for DBAs and Developers, Linux Recipes for Oracle DBAs, and Oracle DataGuard 11G Handbook. Thank you, Charles. Jeff Branning, some of you have seen him in lots of different presentations, including the presentation on RAC and VMware this morning. You can ask him, because he likes to talk about it, what an Oracle community tribal shaman in EMC is. It's a rather interesting story. Certainly is the subject matter expert in Oracle in general at EMC, the licensed attorney. He's also from Duke University. I happen to be a Duke University basketball fan, so we've been able to talk about that quite a bit. My niece is there right now. Was the first Oracle-focused NetApp employee way back in Stone Age in 1997, responsible for validating the NFS in general with Oracle. Obviously, that just created a small little industry. Started at EMC in 2005. He currently is running Oracle on virtualized hardware in general. Obviously, a regular speaker at just about every event that you could think of. I first saw Jeff about 5 years ago, and part of my lexicon is directly due to Jeff in certain areas that I haven't even told him about. Okay? And of course, he is the blog master of the Oracle Storage Guy blog, when you can get these slides and these references. Okay? Howard Ostro. Howard is an ex-Oracle employee who was there for more than a decade, another Oracle Certified Master. He was actually part of the testing team for the Oracle Certified Master Practicum, so if you had some trouble taking that or you didn't like it, go blame him, not me. His professional focus, again, Linux, Oracle. He spent about 5 years working as a director for delivery for Oracle University, so basically he managed the delivery and the rollout of all the classes. Thanks, Howard. All right. Chris Williams of Cognizant Nope, I said that out of order. Did that out of order. I was meant to go with Dave, but let's do Chris. Chris, a senior manager and principal architect in consulting professional services at Cognizant, has a number of very interesting stories to relate to you. Been doing this, obviously, for a long time. Key role developing Cognizant's virtualization consulting models. Has been involved in virtualization of infrastructure for every possible database management system. He looks like he's only about 35, so he started doing this stuff when he was 9. And previously, I've led a global virtualization team that had a lot of folks in it, including 50 VCPs. And Dave, out of order, CTO, Chief Evangelist, founding partner of House of Brick Technologies, another Oracle certified DBAs. They all are up on this panel. Developed Oracle RAC training on VMware, still used by Oracle training partners. So I remember back when I was at Oracle University, this was an extremely difficult task to actually roll out to the partners, and Dave solved all of those problems. Consulting to over 50 organizations on virtualizing Oracle database and infrastructure for Oracle databases. And obviously, you've probably seen him as well at pretty much every major event that speaks to Oracle on VMware, and is easily one of the top spokesmen on earth. Principal architect since version 2.5, way back then, back when we didn't have as much viability as we have now. So he was VMware before VMware was cool in Oracle, right? Presented the case studies all the way back in 2007, right? In IT terminology, that's really about 75 years ago. Okay? And finally, an Oracle architect in general, content-based, delivered by VMware to the partner network. You'll be hearing a lot more of that in the relatively near future. Okay? All right. So without further ado, let's get to some of the questions. Let's see what these guys have to say about some of the more important aspects. So what I'm going to do here is just simply call on one of them randomly in order and see what they have to say and see if they can get some extremely rich content in about a 2-minute period. Huh? All right. Mr. Charles Kim, do me a favor here and please explain the difference between Oracle's concept of the database cloud and maybe VMware's, or the more common way of thinking about the cloud.
All right. So basically, the primary difference between the two is really the implementation method, right? So with the Oracle Database Cloud, you have two options to implement. You can actually implement or architect the database within a hypervisor, which is what all of us are used to doing, or you could actually implement RAC on a standalone physical hardware, or implement Exadata. And so the key thing is that Oracle is saying that RAC has virtualized database services that will help you with the elasticity and the agility and all that such, right? And so you can actually create a schema inside of a RAC database. You can provision an entire database for your application users, or you can provision the entire RAC cluster for your application users, right? And at the same time, Oracle addresses the scalability requirements because you can scale a node vertically by adding CPUs, memory, HBAs. At the same time, you can scale a RAC environment horizontally by adding more computing nodes to the server pool, right? And so some of the key virtualization features that Oracle provides are things like instance caging, the ability to assign a number of cores to an instance, right? So that works in conjunction with the database resource manager. Now you can dynamically increase or decrease the number of cores for an instance. Right, so and you actually do that with one init.org parameter called CPU count. And so at the same time, Oracle also provides the quality of service and provides automatic workload management as well. And so most of us, people on this panel, might not agree on everything, but one thing that we all agree on is that RAC on VMware works well. Right, and so I think you can take the synergy of a great product from Oracle, RAC, and another great product from VMware, vSphere 5, right? And the synergy of these two products make an awesome product for you in the virtualization space.
Thank you, Charles. Dave Welch. So Oracle 11g has some new interesting ways of managing memory, automatic memory management. We can speculate as to why those parameters exist, but please explain to me the limitations on them, particularly when it comes to using huge pages.
Okay, happy to. 11g01 introduced the capability for automatic memory management to also deal with the PGA. I hate that name. They shouldn't call it the Program Global Area. They should call it Dynamic Sort Space, but which is malloc. It's variable, malloc out of operating system memory. The problem is when you use the max memory parameters that are new in 11G Release 1, you break huge pages. Now, automatic memory management, I would contend, is more of a configuration nicety than a performance option. And huge pages, on the other hand, very definitely is critical. I don't care how large or how small your memory map is. It's the difference between the Oracle kernel having to map millions of memory pages and just a few thousand. Huge pages can have a dramatic positive impact on larger SGAs. So just be aware that there is what I call that bug in 11.201 in particular, where that is broken, and you don't want to enable those Oracle level memory parameters. They fixed it in 11.202, which is a good thing. And they also have a brand new parameter whose name escapes me that basically in 11.202 that says don't start the Oracle instance if you can't allocate and validate huge pages. So strong encouragement to all of you to always, even on the Windows side, large pages, Linux, huge pages, never, ever, ever, for any purpose, create an instance or run an instance, but what huge pages is not enabled, even if it means if you're on 11.201 and you've got to sacrifice the PGA dynamic feature, big deal. It's a small price to pay for the uplift.
Thanks, David. Howard Ostro, you are a particular expert when it comes to delivery of education services. And I want to ask you a multiple-part question. I want to ask you about the specific benefits of using vSphere or any of the other VMware products over other virtualization technologies in education delivery. And I really would like to know specifically how Oracle deploys, or they used to at least, and how they possibly deploy now virtualized environments in the education department. And then finally, what do you see this trend?
Okay, so in education, delivery is the primary goal. Well, you're taking classes. So essentially, you've got an instructor, you've got to manage that, you've got to manage the facilities. IT is not always the biggest concern. As you move from raw iron to virtualized environments, which does make sense, a box in an education environment, your return on investment is how many classes you can run on that, how many students you can run on that. Okay, as you do that, you may go from 10 hosts to 100 VMs, maybe 200 VMs. Manageability is really the key when it comes down to that. You don't have a large IT staff. None of the education companies that I do work for or that I have worked for have large IT staffs. And the other thing about that is if you're taking a class and anything happens with your education experience, you want your money back. That's not funny money, cost center money. It's quite real. And in education, a refund is something you don't want to do. So you have to deal with the manageability of potentially hundreds of VMs with students that are sitting in classrooms. So you want to have a view of that and be able to react quickly. Things like vMotion. If I know something's going to happen, I don't want to just send an email that says, hey, I have to take this box down. It's running maybe 10 VMs because something's going to happen. You don't want to send that to the instructor. What you really want to be able to do, move everybody over, and no one knows the difference in the ideal world. And once again, if you have to refund money because somebody doesn't have a good experience, it's going to be a problem. So resource management, the ability to leverage your boxes, run as many classes as you can, which means you spend less money, and manageability are really the key in an education environment.
All right.
In terms of Oracle,
yeah, go ahead.
In terms of Oracle University, it's a really interesting story. Oracle University went from 10 to 14 Sun servers, depending upon who you talk to, in 2003, and actually went off those to basically x86-based boxes from Dell. And the problem they had is they had 8 to 10 classes running on that big box. If anything happened to that big box, you didn't want to be in that class. Now what they did is they took one box, one class, and that's how they mapped it. Interesting story. The classes ran too quickly. The labs actually ran too quickly when they did that. Well, eventually, of course, we had the .com correction, and people spent less money on education. So what happened is OU had to spend less money on boxes. So what did they do? They virtualized. Instead of having one class, One box. One box, multiple classes, multiple virtual machines. Now, they use Zen. They use Zen directly. And that's partially for cost considerations. Interestingly enough, that caught the eye of the Linux product development group. They saw that, and hence came Oracle VM. So the needs of a training organization, to some degree, drove what ended up being a product. Right now, the entire back end of Oracle University is virtualized. It is using Oracle VM. It is an Oracle product. That does make sense. Okay. Now, they've also moved to where the desktops are now virtualized. They do use VirtualBox for doing that. And once again, that is a product that they've added value to. That comes from open source. So here's a case where the entire organization is virtualized. It gives them a better return on investment. And the other thing it does is it actually makes it much easier to take care of automation.
All right, Howard, thanks. We're going to get back to that in a minute in a different question, but I want to change subjects a little bit. Chris Williams, tell me about Solaris containers and how other so-called hard partitioning methodologies compare to vSphere.
Well, it's actually a good question, and we hear this in our client base far more often than you would think or realize, especially given an audience of people that are going to be much more technical like we would imagine that we will have here. But the fact of the matter is we're talking about different methods of virtualization that have specific weaknesses. Solaris containers is what we classify as OS virtualization, where you are creating multiple containers that share a single kernel. So you have, in effect, the same kind of situation that you have with stacking multiple instances in a database. If anything happens at that kernel level, everybody who is subject to the rules of that kernel dies. Moreover, what happens in a container-type environment is if you need to do things in user space or get out of user space into the kernel, that's considered bad juju. And oftentimes, when we are trying to master our own individual worlds, we want to be able to access things at that layer individually, and we want to be able to maximize the control that we have across the board for every one of our individual environments. So containers tend to limit us in that way. When, by comparison, you look at vSphere as a virtualization platform, you have a dedicated hypervisor that allows multiple kernels and thus multiple operating systems that, in effect, only have to be able to address that Intel processor underneath. But now you've got distinct worlds that are absolutely isolated, absolutely protected from each other, and if you want to destroy your own little world, you now have the ability as a kernel guy to kill yourself, and you don't have to take everybody else with you when you do that. So,
right. Thanks a lot, Chris. Mr. Jeff Browning, please tell me what happened with the infrastructure virtualization for Oracle at EMC.
Thanks for asking, Don. The EMC IT story is very compelling. We are running the fourth largest e-business suite implementation on planet Earth, so far as I'm aware, about 8 terabytes in a single instance. We're doing about 8 million IOs a day. We were originally on a physical platform that was E25K, had 256 cores. Our performance was bad. I guess that's just it was really, really stinky. We re-platformed, that was the real key, onto x86. Initially decided to go with 192 cores on a UCS blade system. When they moved the database over, which by the way they did in a weekend, 8 terabytes moved in one weekend, they started running on that 192 cores and found we don't need that. They were running less than 10% CPU utilization. They dropped it to 128 cores and still have very, very low CPU usage. So first savings, big savings on the Oracle license cost because of the vastly reduced number of cores. The other thing is by virtualizing the RAC nodes, EMC IT is able to migrate VMs, even though it's a single node per server situation, okay, which seems non-intuitive when you think about it. The node is almost completely utilized by a single VM. So there's not a lot of consolidation opportunity. But by virtue of having it be virtualized, it gives them a lot of agility, right? So they're turning over the hardware very frequently, on the average about every 6 months. And by doing that, they maintain fresher CPUs. Now, Oracle is, again, charged on the CPU cost. It doesn't matter how hot that CPU is. Same cost. So by getting onto more recent hardware, they're able to drive more transactions through the same costs, lowering the cost per transaction.
There is,
so,
go ahead,
go
just
ahead.
finish up.
The net is savings of about $7 million a year. So decent change.
And there are significant pieces of collateral, white papers and such, and obviously, as I just said before, Jeff can talk about this for quite a while. All right, so if you want to talk about some of these things afterwards, please feel free to find any one of us. As I said before, we'll all be outside selling books and signing autographs afterwards. So, Mr. Dave Welch, please tell me about paravirtualization. How does Zen work? Tell me about, maybe make some comments on some of these interesting signs that we see on taxis that are surrounding the buildings here.
Oh man, Zen. We're talking about Oracle Virtual Machine, of course, which is one of the Zen variants. Paravirtualization has to do with the perceived need to modify the Linux kernel for certain capabilities or even performance. I'm quite happy with the way that VMware handles it because we don't paravirtualize the OS itself, but we paravirtualize I/O and network drivers. Probably implied in the question but not stated, so I'm going to leverage it. My big beef with Zen is what's called as the parent partition. It's the requirement to take apart a stripped down Zen copy and run it on top of Zen that's running on native hardware. And that has several disadvantages. It's got tier 1 network and I/O disadvantages. It's got security problems because security analysts ultimately all agree that the ultimate way to reduce the security threats is to reduce the target surface of the footprint. ESX has got 140 meg. Zen with its parent partition, you're a lot larger than that. The problem with the parent partition is I've got to use the same device driver, network or I/O, in the base hardware as I do in the parent partition. And it's very difficult then to code that driver. What am I coding for? Native hardware I/O, virtual. I've got to split the difference. The code becomes more complex, and it works just great in a tier 2, tier 3 environment, but start scaling multiple tier 1 workloads on top of the same Zen server, you're going to have a scalability problem. It's inherently anti-HA, meaning there are an awful lot of patches that come through that have to upgrade Linux that take down that parent partition that have nothing to do with virtualization whatsoever. So the taxi cabs, it's kind of interesting, claiming that Oracle performs better than VMware. Oracle Corporation's never produced any type of study or numbers to back that up, and the parent partition driver issue that I just described pretty much debunks that claim.
Thank you, David. Thank you a lot. I don't know if you've all seen some of these taxis droving around here, but obviously they found it important enough to pay a lot of taxi drivers some significant tips to do this, right? Chris Williams, this is an interesting question. How is it in some cases multiple VMs running on vSphere and the respective aggregate performance on a single host actually exceeds the performance of a single OS running on bare metal?
Yeah, it's a great question, and people ask us all the time, how did you do that? And what we're talking about is the ability to take multiple virtual machines and stack them on the same physical server and get better performance out of them. And really the weakness boils down to something that I actually know and love very dearly, and that's the Linux kernel. I'm a Linux guy myself. But the fact of the matter is that there is a known weakness of serialization at the OS layer within Linux. You can eventually hit a performance wall as a result. When you virtualize, we're intervening by adding a hypervisor that is designed to basically do one thing and do it very, very, very well. And when you do that, adding the other capabilities around management of I/O, we're actually able to leverage that hypervisor to have multiple virtual machines running Linux that, in effect, give you better performance on a single box than you could ever achieve natively. So there, in effect, is really no magic to it, but it's understanding that when you can get a piece of software that is able to manage critical components and do just those things well, you wind up with performance numbers that are very, very impressive.
Thanks, Chris. Charles Kim, you've been involved in a lot of recent significant migrations. Sometimes customers are intimidated by that. They find it difficult. Tell me, what's the easiest way to move a production database from a non-virtualized infrastructure environment into vSphere?
All right. The key point here is to move your physical to virtual, right? And to do it with near zero downtime and zero risk, right? So with those concepts in mind, the easiest way to perform that migration is to leverage actually an Oracle product called DataGuard, and in particular the physical standby, right? And so Oracle in the 90s used to have a slogan that said size does not matter, right? And so in this particular implementation method, no matter how large your database is, be it 500 gigs or 20 terabytes, the amount of downtime that you encounter should be very similar. And so the concept is to take a backup of your primary database, in this case what's on your physical world, right, and clone that over to your virtual guest and stand up a what we call a physical standby. And by doing that, right, you actually take the redo transport from the primary, right, and set up managed recovery on your virtual standby, right. And so at this point, you would take a brief outage, and I've seen as low as 5 to 10 minutes of an outage, and you perform what we call a graceful switchover from your physical to your virtual, right. And now your virtual is running your production database, right. And so let's say hypothetically something goes wrong within 3 days or within a week because of some network issue or whatever, right? And so you can actually take another brief outage window again and convert back and switch and do another graceful switchover back to your physical, right? And so by doing that, you guarantee zero data loss, right? And so this particular migration method becomes almost risk averse, and the outage window is insignificant.
Charles, you've done these at some recent sites.
Absolutely.
Okay. See. Jeff Browning, this is a simple question for. What's the real value of VMware or running Oracle on VMware?
The real value is all about the money. I've said this many times. I've made a very, very good living for the last 14 years of my life by understanding one thing, the cost of running Oracle. Oracle is the most expensive piece of software on planet Earth for general purpose use, excepting things like e-business suite, SAP, which are not general purpose software. So you have to ask yourself, what is virtualization really for? Virtualization is about improving utilization of resources by consolidating. Now, Oracle themselves have done studies in which they have shown that most Oracle database servers are running at average CPU utilization in the low double digits. Okay, so there is a consolidation opportunity here. VMware's study is even lower. They show Oracle CPU utilization on average at about 7%, so high single digits. The bottom line is there are many Oracle database servers that are running at very low utilization. The Oracle license cost is on that CPU. That means the majority of the Oracle license cost is simply being wasted. You can recover that money by virtualizing and improving your utilization of the hardware. We've done a study in which we looked at a 16-core, 4-node rack, quad processors. So 32 total license cores, 16 cores per box. That configuration on list price has a license cost of $2.2 million and annual maintenance of about $500,000 a year. By implementing virtualization and assuming only 2-for-1 scaling, which is very conservative, your ROI on your investment in vSphere in that configuration is 2,012%.
So
about
you
20
can tell that Jeff could easily argue this as an attorney, very easily, right straight through that.
There's a lot of money to be made here, my friends. So,
David Welch, tell me about jumbo frames and when you should use them, under what circumstances, and why they're so important.
Oh man, jumbo frames. Let's start off with the politics. Your network administrators, if they haven't done it already, will cringe when you start talking about jumbo frames. You need to bribe, cajole, threaten, plead, beg, cry, do whatever you need to do to persuade your network administrators to configure jumbo frames. Some of the vendors make that easier than others. Jumbo frames is not going to buy you much at all in a giggy environment, so don't bother. For most workloads or just raw network proofing, you're going to get raw network benchmarking, you're going to get maybe 10% lift out of it, so it's not worth the pain. But how many of you are a 10 gig E or north of that in the room? Okay. Do it yesterday. Jumbo frames with network IP-enabled storage will provide as much as an 85% throughput improvement. It's a millstone around your neck if you're trying to get into IP-based storage and you haven't done it, and it's absolutely critical to do it. You're going to want to use MTU configurations and jumbo frames of between 8,500 and 9,000. Significantly reduces the number of packets flying around, radically optimizes the throughput of the network, and it has no downside in terms of penalty. There's only lift, but it's a very difficult sell politically to push your network administration staff through it because it can be a headache to configure, but it's worth it.
Thanks, David. Charles, let's go back to the line of questioning I had for you before. Once you've got your Oracle customers to actually completely 100% virtualize their infrastructure for Oracle, what's next?
Once you have all your databases in a virtualized environment, the next thing is to continue and find ways to reduce your CapEx, right? And so what you do next is to start standardizing on the number of OS versions that you have. For today, if you're on Red Hat today, you should either be on Red Hat 5.6 or Red Hat 6.1. And as you standardize on your OS templates, right, you should also incorporate all the reference architectures and all the best practices, like David mentioned, incorporating jumbo frames into the equation, incorporating huge pages into the equation, right? And then once you've standardized in the OS, now you come back to the database size, right? On the database side, our current versions of databases that we have today is 11.202, or if you're not on 11.202 yet and you're in the process of upgrading, you either be on 10.205 or 11.107, right? And so a lot of us still have legacy applications that doesn't support the latest releases of Oracle. For example, we might have a 9i or earlier version of 10.1 stragglers out there. Those should be more of an exception than a common occurrence, right? And so now at this point, you would have your number of databases versions standardized, right? And the next thing would be to start standardizing on your init.org parameters, right? And then continue on, standardize on the character sets that you have. So, and these standardizations will allow you to consolidate more schemas into a central database, right? And then once you go beyond that, right, a lot of us tend to create databases with features that we hardly use. And the classic example would be intermedia, right? And so you get to the point where you standardize further by getting rid of all these environments and taking all these features that you don't use, and that will allow you to even consolidate even more. But more so, it lends your environment to be more secure because you don't have to upgrade those environments, and they're not subject for vulnerability.
So, Charles, I accidentally coined a term, I think, the other day called templatization. You do much of that?
Yes, we do. We get to a point where you start building golden images and you start templatizing, right? And the whole objective in this model is have 2 templates on the OS side and 2 templates on the database side.
Hey, don't you laugh at that. You're going to be using that term soon. All right, Howard Ostro, you and I have both been Oracle consultants for a long time. We've noticed something interesting that's a trend in Oracle consulting, that Oracle consultants, whether they're with Oracle or not, tend to have laptops that have a lot of stuff running on them. That's a technical term, by the way. What do they have in their laptop?
They almost always have VM Server on their laptop. And there's a very good reason for that, even though there, of course, is the Oracle VM product. If you look at it this way, a consultant has a laptop. That laptop has to do a lot of different things. You have to fill up your expense statements. You have to type up all your reports. You have to read your AWR stuff, everything off that. Most organizations use Microsoft-based office productivity software for all of that. So this is what you're stuck with. You get your laptop, you get Windows 7. Hopefully that's what you have. And then customers want you to show them, hey, I want you to prove to me how this works. I want you to show me. Customer may have a problem. Say, well, how can I recreate the problem? Good luck with them allowing you to mess with their production database. The answer is usually no, and you know what, no. Okay, so what do? Well, if you want to use Oracle VM, that's a Type 1 hypervisor. That runs on top of your bare metal. Well, your bare metal is your laptop. How would you do that, even if you wanted to? It'd be kind of difficult. First of all, it has 2 basic components. It's got its manageability console, and then it's got the VM itself. The manageability console is hosted on Linux. Heck, that's fine. I've even put it in VM Server. It runs fine, but now you need at least 1 VM. In fact, you have to have one in your server pool. It's the server pool master and the utility master. You're not going to do this on a simple laptop. It's simply not going to happen. So what do? You use a Type 2 hypervisor. Okay, you want one that's flexible and powerful. If a customer says, well, I want to see NIC load balancing, not a problem. I'm just going to add another NIC. They want to see this. I want to see what happens when I go from this amount of memory to that memory. I want to see what happens when I go from 1 CPU to 2 CPUs. You're going to want something like a good quality Type 2 hypervisor, VM Server. Most consultants will usually have 3 or 4 VMs that are constantly there. They're not constantly running, of course, but they're there for general purpose. And it's just very, very important to be able to do that. And VM Server is a great product for doing it.
Thanks, Howard. We've all done this. I think many of you out there have done exactly that, and it's just kind of an interesting aspect of the industry. David Welch, you work for House of Bricks, been very, very successful, great VMware partner. Tell me about the House of Brick 4 test criteria, please.
You're referring to our RAC evaluation criteria. We are, first off, I have to say, I've been a RAC, Oracle Parallel Server DBA, RAC DBA since 1995, which means I've left my quart of blood and pound of flesh in the halls of corporate America. But we love RAC. We absolutely love RAC. We love the RAC challenge. It's a far better clustering stack than its competitors. But we wouldn't wish RAC on our worst enemy if it's not necessary, if there's not technical or business justification for having it. It requires much more complex training. The stack has to be owned by and large by individuals as opposed to entire teams. There are only 2 types of clustering databases in the world, and I don't believe this to be a broad brush statement. Extremely stable or extremely unstable. Now, we've never run into a RAC database that we couldn't stabilize, but the joke amongst, regardless of your RDBMS brand, amongst the various admins is the fastest way in the world to reduce your HA SLA is to install a cluster database. So we can no longer recommend cluster database technology or RAC for a lot of the customers that have it already. I have 4 criteria that I use. First off, do you have a published SLA that demands production transactional continuity HA in 4 minutes or less? If you don't, single instance Oracle on VMware can do an HA failover and be booted and have the listener up in that amount of time. Got to answer yes to at least one of these to install or keep RAC. Or have you coded or have configured your middle tier to use the fast connection failover or ONS capability? Or are you addicted to the rolling patch upgrade framework that RAC provides for a subset of its patches? Or is your scalability so large that at the end of the day, you can't fit your workload in 32 hyper-threaded vCPUs, which is 99.5% of our Tier 1 production customer stacks will fit in that. If you can't answer yes to at least one of those, probably don't need RAC. Now, out of fairness, there's a blog out there, VMware HA is not RAC. Corporate America CIOs and architects that we review that blog with seem to feel like the vast majority of what it talks about are corner cases.
Thanks, David. Jeff Browning, tell me what the best way to lay out storage is for database in general, just RAC or non-RAC.
Okay, so there's 4 high-level configuration options, other than the ones that are silly. I won't cover the ones that are trivial. Of those 4, there's actually 3 that are popular and 1 that is not. So let's go through those. Configuration 1 we call RDM on block storage, can be either iSCSI or Fiber Channel. RDM is mounted onto the VM and then used as an ASM disk. And you build your shared storage on ASM. That's configuration 1. The advantages of that are that you can support physical nodes, that is, physically booted nodes in the cluster. It also makes it easy to transition from a physical environment to a virtual environment. If you have LUNs that were mounted on a physical box that were already running ASM, you can simply make those become RDM and bring up a VM and mount those very, very quickly. Easy transition to VMware. Disadvantages with the shared SCSI bus, there is no vMotion in that configuration. All right, so that's a big negative. It's complex, it's difficult to work with, it's not the main sort of stream that VMware likes, right? So that's configuration 1. Configuration 2, also block storage, can be either iSCSI or Fiber Channel over Ethernet for that matter. You take those LUNs, you give them to ESX, you turn them into VMFS, and you configure VMDK files, and you put your database there. Now, several issues there. Number 1, your VMFS volumes must be eager 0 thick. Number 2, you must enable the multi-writer flag on each and every VMDK file that you use with RAC. That's a little bit of a configuration issue, but not one that you can't overcome. Number 3, you have a limitation in the number of simultaneous writers to a VMDK file of 8. Therefore, you can only scale to 8 nodes. Advantages are it has a lot of value add in terms of the VMware stack, things like VAI, VOSA, storage vMotion. These all work beautifully. Primary disadvantage, no physical nodes allowed. Obviously, if you're storing your database inside of a VMF file system, there's no visibility in terms of shared storage for those data files to be seen by physical nodes. All right. So then you have the 2 block options. Number 1 is direct mount NFS onto the VM and use Oracle DNFS. This is a very nice option, okay, and I have to admit I like it a lot. It completely bypasses ESX. You can have physical nodes, so you can have a mixed physical virtual rack. You can also easily transition from physical to virtual in a NAS context. You can use storage-based replication tools like EMC Replication Manager and NetApp Snap Manager for Oracle. Those work great. There's not a lot of things about this that's not to love. Okay, so direct NFS is a very viable option. We've done performance studies, and the performance is very, very good on VMware with that option. The last one, which I think is not terribly interesting, is NFS data stores with VMDK files. Our study shows there's a big performance penalty for doing it that way, so I take that one off the table. So that's
David,
how I would lay it out.
You want to add anything to that, possibly?
Well, I would just add that, and Jeff already mentioned it, and that is our customers, we really are watching them walk away from the Oracle support concern and being able to rapidly replatform a terabyte or 2 of storage in minutes, which you can't do. There's no tooling on the planet currently to do that. And they really are running toward VMDK in a hurry with our blessing. Why? Jeff mentioned it already. You've got fault tolerance, storage vMotion. You've got an increasing plethora of tooling at the ESX vSphere level that you walk away from if you're not using VMFS-backed VMDK. And it's transparent for all intents and purposes.
I would generally agree with that.
So, Chris, why don't you add to this little fray for us a little bit? Tell me how you at Cognizant implement RAC on VMFS in an extremely innovative way that was actually supported before Oracle supported RAC on VMFS.
Oh, thanks. Yeah, I've been chomping at the bit when I heard some of these, but we've had some really good discussions prior to starting this panel about all of these objects. What we did, I like to say, came out of 10% inspiration and 90% desperation. But what we wound up with was something that we call the iSCSI Gateway VM. And if you will, take a virtual machine, give it a bunch of disk as a VMDK, optimize your storage I/O for that disk on your data store as you would want to optimize storage I/O on any VMDK-based system, and then reshare that storage as an iSCSI share over your virtual machine network or a dedicated network on a distributed virtual switch, and then have your individual cluster nodes mount that as their shared storage instead. The nice part about this option is that we found that it works consistently well across every type of VMware topology you can think of. We even have been able to demonstrate that it works on a cloud service provider type of infrastructure. It works great with Fiber Channel. We've exceeded the ability. In fact, the 8-node situation, our first client had 16-node ESX clusters that we had to deal with. Works fabulously well there. And probably the downside of it is that the first time you explain it to people, we usually get a big text says, huh? But
that
if
was
you
me,
can think,
by the way.
But if you can think, what I've done is essentially implemented a virtualized iSCSI SAN inside of my underlying storage area network, be it Fiber Channel, NFS, or et cetera, the blocks tend to fall together from there.
So, Chris, let me follow up with you on this. You've got a couple of extremely significant, very high-profile wins, incredibly significant implementations of companies that you all would know off the top of your head, which, of course, we can't mention. But please tell me everything that you can without mentioning those company names about those successes.
Okay, so the first client where we did this, by the way, we virtualized RAC, and RAC was actually deployed there intentionally to be the backup of an Exadata platform. So we were actually using virtualized RAC clusters to support both a development environment as well as provide failover for an Exadata platform. We wound up being extremely successful there. And as a side note to that, what Dave was mentioning about turning on jumbo frames, we had 12 gigabyte rack nodes that we were able to vMotion across DRS clusters in 12 to 15 seconds. So if you don't think jumbo frames is worth something, absolutely it is. More recently, we've continued to tune the iSCSI Gateway VM and have tuned it such that it can be a fault-tolerant VM in and of itself, again, running on a Fiber Channel network. So imagine having a 4 or 5-node ESX cluster with a 3-node rack implementation and a fault-tolerant gateway VM, and we purposely placed the primary gateway VM and the master node of the rack cluster on one single blade and powered it off. And the beauty was that in terms of transactions, nothing happened. The system continued to run normally. The failed node from rack was restarted in approximately 60 seconds, and fault tolerance protection was re-enabled on our gateway VM in approximately 2 minutes. So very, very successful, and our clients have been very pleased with the results.
And believe me, these companies, it's all important to you that this stuff works right. Mm-hmm. Charles, since Chris mentioned Exadata, tell me about, is there any overlap between what Exadata does and what VMware can do with vSphere for Oracle?
Before I answer that question, do the people in the audience know what Exadata is? Wow, very few people. So let me give you a really high level of what Exadata is, right? Exadata is basically infrastructure, software, and hardware all integrated into one product, right? So Exadata is marketed as a database machine. Also, from a virtualization perspective, they market it as a cloud in a box. And so Exadata has a Linux server, it has a Cisco switch, InfiniBand switches, it's got flash cache, it's got a SAN storage server as well. And so most of the customers that I know who are on Exadata, they're driven strictly for the utmost performance and have the highest uptime requirements in terms of high availability. And so, and you see a big push by Oracle nowadays, pushing Exadata for consolidation. But what you see in the industry is that most of the people are there for the performance aspect, right? And so again, Exadata leverages RAC, right? And earlier, like I mentioned before, RAC has a lot of the virtualization features, right? For example, like I mentioned again, the instance caging, the automatic workload management, the quality of service, right? And so Oracle within the RAC components, right? The quality of service is a big component in that piece. Just imagine voice over IP, right? And so you know that in the voice over IP plan, right? Your voice plan always has a higher priority over your data plan, right? And so likewise, what some of the RAC services provide in terms of virtualization, right, is that your mission critical databases will always have a higher priority over your less mission critical databases or non-mission critical databases. And so RAC encompasses a lot of the virtualization features that you see, but however, it is not the traditional virtualization that you and I both know from vSphere.
So what about from a consolidation perspective? If your customers and they were looking at, say, both of these kind of platforms, which way would you advise them to go?
Well, from a consolidation perspective, you don't actually see much of that from Exadata, mainly because of the cost. Like I mentioned before, most of the people are implementing Exadata for pure performance.
From a data warehousing perspective, mostly.
Data warehouse and also from OLTP. But the thing is that we also have an Exalogic platform as well, and now that's going to be virtualized.
Yeah, there's a whole other subject.
It
right?
sure is, yes.
So, Howard Ostro, I've also heard that there are some ways to simulate Exadata from a testing perspective. Any insight into that?
Yeah, actually, I built an Exadata simulator for Oracle Consulting. Now, to do so, and you want to do it correctly, you need really two components. You need to have the Exadata cell. The Exadata cell is the actual footprint that actually talks directly to the storage itself. It runs what amounts to as a version of OEL, and it has very special services that are on there to what they call offload, do query offloading. You also, of course, would need to also have the Oracle server itself. And that's what Exadata really is. You pull the rack apart, and that's what you're going to have. You're going to have a number of blades that are going to be there. Well, so much blades, but small boxes that are going to be there. They're the Oracle servers. Then you're going to have other components there, and those boxes also are going to be for the cells. So you really need to simulate them both. It's exactly what I did. I created one VM, and that was the Exadata cell. Cut up 12 LUNs, presented them. You have to use the correct utilities to do that. Then I created another VM, installed. At that particular time, it was 10.2.05. Brought that up. And it has a great little utility there that actually plumbs the whole thing and makes it look like you actually have that InfiniBand back end, and you can sit there and run all the queries you want, look at the execution plans, and it'll tell you whether or not those queries are going to be offloaded. And that's what a consultant really needs to do to show somebody, hey, this really is transparent. Now, if you think about that, those are two VMs. You really can't do that on a single laptop with a Type 1 hypervisor. So what did I use? I used VM Server. VM Server carved my two VMs. It was easy. I had a very easy step-by-step, and every consultant, no matter what their skill level, was able to deploy it, and it was very, very effective at communicating the ability to use Exadata transparently to customers.
Isn't it great how all this stuff comes full cycle? Dave Welch, let's end this this part of the panel discussion by just talking to me a little bit about apples-to-apples testing and what test you use at House of Brick and why that's so important.
Man, easily in corporate America for the last 6 years that we've been doing this, 50% of the customers do not get good performance out of the box. 100% of those are resolvable through configuration. The vast majority of that comes down to storage. They've done, and here are the 5 common sins. They get so used to the Tier 2, Tier 3 memory CPU consolidation that when they set up their Tier 1 proofing environments, they assume to do the same thing with storage. And they'll fan in 15 or 20 workloads in their proofing environment to a single data store or LUN and saturate their SCSI queues. So as a DBA, as a production DBA, I want my pager going off if any device in the storage path has SCSI queues that exceed the teens. It's like a buffer busy wait insert for a DBA. You don't need more capital. You need to realign and get closer to a 1-to-1-to-1 correlation between your workloads, VMDKs, VMFS, data store, LUN, and assume that out of the chute. We insist that our customers look at 20 to 30 millisecond average read times for uncached random reads with colliding writes. If you can't do that, fix your storage. It's not an issue having to do with VMware. You're going to be throwing arrows at VMware. We don't like our devices, our spindles, any more than about 50% busy. If they're busier than that, get more spindles. We love Iometer, the Intel the free I/O benchmarking tool, and we insist that people, if they can, if the cache isn't too big, pierce the cache with a 32 gig or a 60 gigabyte write, and we should get at least 60 megabytes per second streaming. That's not that good of a number, but frequently people show storage paths that fail that, and that is their VMware proofing environment. Don't do apples to oranges. Give your VMware proofing environment the same type of storage that you would give your native Tier 1 production, and by and large, you'll be fine. Those are the biggest sins that we see.
So I'm going to ask one more question, and then I might ask them all if they've got some other things to add. But I'm going to ask one more question, which is the most important question of all of this. And each one of them I'm going to ask to respond in 30 seconds and a minute as we're coming to a close here. The question is, Charles Kim, to start with, what do you see as the future of Oracle and VMware?
I see a lot of Oracle RAC on VMware. I see a lot of benefits that vSphere complements with Oracle RAC, and the synergy of those two products, making an awesome product.
Howard Ostro, what do you see as the future of Oracle on VMware?
I think for the majority of people out there running Oracle databases, and it comes from me being a consultant besides being the person who took care of the management of that part of OU, majority of you have databases that are not running near at the capacity of your hardware. You're just not. There are going to be some of you who are. There's no doubt about it. Virtualizing is really, really important to getting the most return on investment out of your hardware. You have nothing but money savings out there, and you really should be taking advantage of it.
Jeff Browning, same question.
I think Oracle is going to blink. That's the bottom line. Within the next 6 to 12 months, and I'm already seeing this with the people that I know at Oracle, Oracle, of course, does not speak with one voice. They've got tens of thousands of employees. But the general thrust of Oracle right now is actively hostile to VMware. I think that's going to change. As Oracle kind of wakes up and sees what their customers want. Right now I have Fortune 100 companies breathing down my neck trying to get a handle on this issue of how to virtualize their Oracle database servers with VMware because they realize how much money they can save by doing that. And as those customers put pressure on Oracle, Oracle is going to have to change their position to become at least neutral. I don't care if they become positive, but stop being actively hostile. At that point, I think the floodgates will open and there will be a vast increase in the percentage of Oracle database servers that become virtualized with VMware.
Sort of like what's happened with SQL Server.
Exactly.
Dave Welch, please add to that.
Oh man, I'd love to comment on everything that's been said already. Two things that I see in the future for Oracle. A future where DBAs will do their homework and understand that for the last two major releases, 4 years, ESX has been transparent to Tier 1 workloads when properly configured. For anything other than a benchmarking team, and when you identify the latencies, they're laughable. They're so small. The second thing that I see is the DBAs understanding our Tier 1 customers' experience for the last 6 years, and there's never been an exception to this. It is Oracle support's practice to take all calls, including when the customer is fully disclosed as running on VMware, and including when the problem is nowhere to be found in Oracle's knowledge base.
Chris Williams, finish up the discussion first, please.
Wow, I think in terms of agreeing with everyone else that you've heard here, I agree that Oracle is destined to blink, and the theme that comes to my mind the most, being the Star Trek fan that I am, is that resistance is futile. It's only a matter of time before Oracle will have to move into the virtual world, and they will have to follow along the same lines as other large corporations, as we mentioned with SQL Server. I mean, ironically, you've seen it with Microsoft and Exchange. They've gone from being incredibly hostile to now actually encouraging you to virtualize Exchange. And I think it's just a matter of time before we'll see the same thing out there.
And I would add to that I think that when you look at the taxi cabs that are running around town, it's very clear that Oracle themselves have completely endorsed the idea of virtualization. Now the question is when are you going to get serious about which virtualization? Right? Folks, thank you for coming. The first Oracle on VMware Dream Team panel. Thank you. Please.